catapult uses stored energy to fire an object without the need of an explosive. Within a catapult, there are three energy storage mechanisms, which are tension, torsion, and gravity. The objectives for this project were to build a catapult that was able to throw away an object. Also, we were going to measure the displacement, the initial velocity, the final velocity, the acceleration, the initial velocity in the y-axis, the final velocity in the y-axis, and the angle.
I'm going to explain the workings and the calculations we did for our project. First, we calculated the acceleration by using the formula of acceleration is equals velocity over time. First, we have to take into account that the object had a displacement of 117.3 centimeters. So what we did was to use that quantity and divide it over the time, that was 1 second, and we got the same quantity, that is 117.3 centimeters over second squared. Then we calculated the velocity with the formula that is velocity equals distance over time. So we did the same thing, that was using the displacement that the object already had, that it was 117.3 centimeters over 1 second, and we got the same quantity. We calculated the parabolic throw. First, we calculated the final velocity using the formula Vy equals Vyo minus gravity times time. But we didn't have an initial velocity, so we assumed that it was 0. So we have that the velocity is now gravity times the time. So we did that, and we got 490.5 centimeters over seconds. But remember that we said that initial velocity equals minus final velocity, so we get the same result, but we hit a negative, but the same result but negative. We calculated the initial velocity. We use this formula. So we put the VXO, that equals 117.3 plus 490.5 centimeters, and we got that it was 254,349.54 centimeters squared over seconds squared, and then we took the square root out of that, and we got 504.33 centimeters over seconds. Then, and last, we calculated the beta. Yes, the angle, I think it's called beta. And we did with the formula using cos minus 1 over BXO, times BXO over VO. We already have these quantities from before, so we only needed to exchange them. And we did, so we put cos minus 1 times 117.3 over 504.33 centimeters over seconds, and we got that our beta was going to be 76.55 degrees. And that's how we calculated everything.
In conclusion, we think with the appliance of this experiment, we have reviewed some of the most important topics on this semester, like storage mechanisms, like tension, torsion, and gravity, as well as vertical throw in speed, velocity, and distance, and Newton's first and third law. By applying all of this in one experiment, we have seen the uses and functions that all of these theories have and can combine into the real world. And as I said before, it helped us recap all this information for the final exam.